Thank you very much. Well, I try to be quick in this presentation, as I think you are so tired of listening some of a lot of presentation. Well, I will try to talk about a little about this OnTruck and OnTruck mission. Our mission is with OnTruck was created to change the lead the road freight transport industry. Just trying to improve the vehicle utilization, reducing transportation and supply chain costs, help truckers and small business to earn more and drive, and lower environmental waste and carbon emission. This is the main purpose of OnTruck, and therefore we oriented the company especially to those this mission, and especially to lower environmental waste and carbon emission. How we impact today in our work? Well, it's easy. Our vision is to optimize the network so we can reduce weight. We can reduce weight in many ways. Just empty space, empty kilometer, and CO2 emission. What we define is the growth well, our way of growth. That is, we have more shipment, we do better matching and better routing, have more jobs that allow our carrier to have bigger earnings, and our carrier are happy, produce better service, and we have more shippers. Okay, that's right. It's so good, but we have to do something to do that. Okay, we are measuring our impact in the market, and it has been observed by different companies like Lean and Green. We win the Lean and Green Award because we were able to demonstrate that we are reducing the CO2 emission. We won the Bloomberg NEF Pioneer 2021. We was selected by Bloomberg as a global award recognition with other 12 companies. Okay, because they realized that we have a huge impact in CO2 emission. Today we are reducing the emission to the atmosphere on 4 million kilograms of CO2. This means around 100,000 trees that have been planted. The equivalent is we plant 100,000 trees, and we get an investment for oil and gas climate initiative. That is the OGCI is a consortium of the largest oil and gas companies that want to invest in companies that reduce the CO2 emission, just improving the market. Well, and then how we apply a spatio-temporal cluster to reduce waste that's the question. Okay, you start moving the industry. We have our industry many times see this problem as a linear problem. This means that the truck start a road and starting picking up loads and full load or not full load when they have to store. Normally we have several constraints. We have time windows constraint, we have hour of service constraint, we have kilometers that we can ride, load, weight, many constraints that we have to consider. Normally we solve this with some algorithms, heuristic algorithms, but what we propose is just to use another kind of solution, because when we start, we cannot see this as a linear. We have different space of time in which we have T0, in which we have perhaps two order that we have to collect. In T+1 we have 4 order. We maintain this 4 order in T+2, but in T+3 we have 2 different orders. This means that our linear view is changing. It's changing across the time. We have 4 dimensions. We have the spatial dimension in which where we had to pick up or drop the order, and the time in which those orders are available. What we had to do is just select the bed road across those this spatial and time dimension in order to improve first the vehicle utilization, reduce the kilometers that we drive, and therefore reduce the CO2 emission per tons that we are moving. How we solve this problem? Well, we solve it with historical information. Historical information, because we have a lot of historical information. With this information, we can pre-calculate cluster. How we pre-calculate cluster? With enhanced ST-DB scan clustering method. What we call it enhanced. This is an internal version that we developed in that, based on ST-DB scan, we are able to look in other moment of times, and we are able to clusterize sites not only across the space and time, just like a time machine. This means that we can simulate where we are in any point of time. With heuristic, okay, we use heuristic to solve the routing problem, the basic heuristic problem, and with the most important part, that is the part that is learning about the reality of the situation, that is a neural network that is element-wise graph attention network. This allows us to center ourselves on the edge of the network, because the graph attention network allow us to represent the power of the graph topology and propagate all the node information to the edge via an attention mechanism. And this allows us to learn which is the best route in each moment to produce the less emission with the vehicle that we have and the order that we have. We have to consider that most of our market is a spot market. This means we don't have vehicles, we don't have our own fleet. We have to use fleet that are available, and every time and in every location. This means that not all the vehicles are available, only some of them that we can use, and we have to maximize their utilization, reducing the distance. And we reduce the emission. Finally, how? Well, in regional LTL and in national international LTL, LTL is less than a truck load. This means that we are collecting different load and fulfill a truck. Was we in the past we used to have 46% of the vehicle empty, and we use to drive with empty 46% of the distance, and use the vehicle up to 40%. And we are not very efficient, and then with the full emission, we are emitting a lot of CO2. And in national and international, we are able to drive less empty kilometers because the distance is bigger, have a bigger utilization of the vehicle, and because we are able to have a better routing factor. With our new algorithm, we were able to reduce the empty kilometer in regional LTL from 46% to 20%. We were able to increase the utilization to 50% indirect. This means that pure spot market increased 10% the utilization of the vehicle, and 75% in the whole marketplace, in the all-day program. And this provides to us that finally that we reduce the emission to the atmosphere in 50% in regional LTL. That is a lot. National and international LTL, we reduce the empty kilometer to 5%. We increase the utilization to 80%, and this have an impact again of another 20% on the emission to the atmosphere. And that's all. You can contact me here any question or through my email, and any question are welcome.
Thank you, Roberto. That was a great presentation. And as I already mentioned, a topic that a lot of people are curious about and want to improve upon. So we do have time for a couple of questions. I think you already covered the impact of reducing these CO2 emissions, but we're curious to know, is there a stage of the supply chain associated with having the highest CO2 emissions?
Pardon, sorry?
Is there a particular stage within the supply chain process that is associated with having the highest emissions?
Yeah, it's normal. In logistics, the height emissions counts because it's difficult to optimize the vehicle utilization, because normally you cannot do it in real time. The problem of routing optimization is an NP, non-polynomial time problem. That means that needs a lot of capacity of calculus to solve the problem. This means that today we are not able to solve closing to real time. What we found is a way that with historical data and all the clustering information to reduce the depth of the calculation, and have the result close to real time. This means that our average calculation time is less than 300 milliseconds for big problem. I say 100 points problem, and less than 2 minutes for 500 point problem, with close to the best solution, with 95% closest to the best solution. That is big enough for our market and improve a lot the emission, the reduction in the emission that we produce to the atmosphere.
Absolutely. And then with that being said, from your analyses, what's one of the most feasible or easiest ways to massively adopt methods for reducing CO2 emissions in logistics? What's something that everyone can easily start with?
I think the first thing is just to understand how you can use the basic algorithm to improve to reduce the empty kilometers. The empty kilometers is the big problem that we have in the industry. Empty kilometers and empty trucks. If we goes to the government center, European Community information, what we've discovered is that as average in Europe, we have over 50% of our trucks that are now traveling across Europe are empty. That is a lot, because it's emission for moving nothing, moving air. And if we can reduce just those emissions, just using more the vehicles and reduce the kilometers just with optimization of the problem, will be good for the planet.
Awesome. Thanks for sharing that one. To follow on, will these changes to supply chain be hard to maintain, or is the harder part in initiating these kind of methods for reduction?
I think it's initiating. More and more customers are asking to have the report. We are providing to them right now report on their CO2 emission just per order. It means that they know how much they will emit with their order, and finally what really we emit with their order, in order to have a clear conscience about the emission that any merchant that we move, the impact of any merchant that we move in our planet. Companies like L'Oreal right now forced to have this information in all the report, in all the billing, because it's important for them. And recently, companies like Amazon, IKEA, and other ones just say that to 2030 they will be emission free or emission compensate in all their movement of merchants.
That's a bold target, but one we hope everyone is able to achieve. We do have time for one last question. Is distance traveled used in your use case as a proxy for emissions, as you mentioned, or do you use something more than just the distance traveled?
We use more than just the distance travel. We use for emission, we use the slope of the road, all the information related to the vehicles, the type of vehicle, the specific type of vehicle, just the manufacturer, motor, age, type of fuel that they use, the slope of the road. We try to look for the best way, just the best path of the to route those vehicles in order to reduce the emission, not only because the 90 kilometers, just for the maximization of the information that we already have. Okay, but this have a little impact because it's the finally is this you can impact with less than 0.2% on the emission, but the biggest impact already is on empty kilometer and empty vehicles.
Awesome. I think that's all the time we have for questions, but if anyone does have further questions for Roberto and wants to continue the conversation,